Hi everyone, my name is Katrina Guido and I'm a PhD student here at the ElectroScience Lab, also called ESL, and I am here to show you around the lab today. Now a little bit about myself. As I mentioned, I'm a doctoral student here. I am researching bioelectromagnetics under Professor Azamina Kiordi, and you'll see her lab a little bit later on today. Once entering ESL, we come into the lobby. Now this is a really great space. One, we host a lot of social events here. So we have a community building committee, and they put on everything from ice cream socials to Super Bowl potlucks to holiday sweater and dessert parties, and those are always the best. Now, not only is this space great for hosting social events, but if you look lining the walls, we have posters and artifacts which depict all of the researchers and inventions that make ESL such a wonderful research center. Now, all of these researchers and inventions have helped to really put ESL on the map in fields such as electromagnetics, remote sensing, radar, photonics, and many other areas. So now ESL is a world-class research facility. So of course we have a library, and this is not all that ESL houses. Most of the student offices, if not all of the student offices, have bookshelves lined with resources. Now if you follow me, you can see my desk. I love to make it homey, which is nice. Other students, not so much. But when you're a student here at ESL, you'll have your own space, you'll have a computer, but you won't be in an enclosed cubicle. You can see that the way our room is set up really encourages that collaboration that ESL is built on.
My name is Trevor Dean, and I'm a third-year PhD student here at the ElectroScience Lab. And today I'm going to show you the class laboratory setup. So CLASS stands for the Circuit Laboratory for Advanced Sensors and Systems. And Dr. Waleed Khalil is our academic advisor for our group. Our primary area of research is in mixed signal and assured microelectronics. And that covers a wide range of material. For me in particular, I'm looking at designing circuits to help strive for better and improved transmitters going forwards to like a 5G standard. So this was a project done by one of our previous graduate students. What he wanted to do was create something that's called an arbitrary waveform generator. If you've ever seen one of these boxes, it's like this long, this wide, weighs like 45 pounds. It's really bulky and hard to use. But the goal, what we could do with using these advanced technologies that we design circuits in, is we can take this really big box and we could condense it down to something like this. That's 3 millimeters by 3 millimeters. And so as you can see, that's a huge size advantage to have. And that's just to kind of give like a general overview of kind of what our goals are. I kind of think of our group as almost like a farm to table strategy as well, where we do this integrated circuit design and then we work up the levels of abstraction as well. So after you finish doing a design for an integrated circuit, we'll then design the printed circuit boards that you'll have to attach the chip to. Then you'll bring it into the lab, we'll do the testing. Everything will go great, you'll write some papers, and it's good to go from there. So this here is an environmental chamber that is sometimes used in our research group. And what this is used for is we're gonna sweep different temperatures or humidity levels and see how it affects the performance of the circuits that we design. One of our students used this recently for a voltage controlled oscillator to see if he was able to maintain the same performance over a wide range of temperatures. This here is a giant electromagnetic interference chamber. So basically what this does here is it blocks out any signals from really coming in all the way up to 10 gigahertz. It's pretty cool inside. You know, if you step inside and we shut the door, you'll lose your Wi-Fi, you'll lose your cell phone signal. So it does work, we have tested that. Here we have a signal source analyzer. And what this is a fancy piece of equipment that can be used to characterize voltage-controlled oscillators, and phase lock loops. Basically, this box will generate the voltage signals to help control our chip, and then it will also measure how our performance looks like. Over here, we have what we like to say is the second fastest oscilloscope on campus. The physics department has one that goes a little bit faster than ours, but it's a really cool tool to use, and it helps us to see the real time what our voltage waveforms look like on our chips. And this is kind of where the magic happens, where we'll do all the assembly on our own. So that's populating the printed circuit boards with the various components, resistors, capacitors, headers. And then we do have some capabilities on campus to do some wire bonding or die bonding to get our chips onto the boards.
Thanks so much, everyone, for taking the time to tour our awesome lab here today. I hope we'll see you sometime soon, and I hope you'll consider coming here if you're considering coming here. And thanks so much.